Okay, so when we talk about domain and range, this is kind of like just some examples. Okay, so remember, domain, discrete data, this is just crazy looking. Okay, discrete equals dots equals list. Okay, that's what you need to remember. Discrete is dots and it's a list. Continuous is connected and it's an inequality. And also on that list, also remember, and it's counted. And for continuous is connected, it's an inequality, and it's measured. So remember that. Discrete, dots, list, counted, continuous, connected, inequality, measured. And I know that counted and connect. I know. I wish I could make it better, but I can't. Okay, I know they all say they start with C, but just go with me on this one. Okay, so let's look at this one. Carnival. Ride tickets at a carnival cost $2 each. Okay, so remember, independent. Here's how I remember independent and dependent. I do dx IY. That's not even right. What am I talking about? That's not. It's x die. I'm sorry. Y'all, it's 5:40. And yeah, I told my kids, I didn't tell everybody else, but my hobby is sleeping. I'm a sleepy lady and I love to sleep. And I'm sleepy right now. So it's Ix dy. So independent is x, dependent is y. Okay, so my independent variable is number of ride tickets. Remember, this is what makes discrete and continuous. This is what makes domain and range. That's what makes this so tricky, okay, is that we have to know, for discrete and continuous, we have to understand everything about the problem to be able to write domain and range. We got to know what our data type is. We got to know what our variables are. We got to know everything to write the domain and range, because ultimately we have to write it in the right way, okay? So independent is number of ride tickets. Dependent is total dollars spent. Okay, so what number of tickets would make sense for this scenario? Well, I mean, that's going to kind of depend. I mean, like, if we're talking rodeo, like, I'm going to buy hundreds of tickets, and I'm going to stay all day. I'm going to get a sunburn. I'm going to get, like, I'm going to have, tummy. I'm going to have, like fried food tummy. It's going to be bad. But in this case, my graph goes up to 10, so I'm going to be honest with you. I'm going to say about 10, because my graph goes to 10. My graph, they're telling me with the graph that you're only buying 10 tickets, even though we know we're going to buy more than that because rides are fun. Okay, now, so then if I'm buying about 10 tickets, I would expect to spend, so if I buy no tickets, I spend no money. If I buy one ticket, I spend $2. 2 tickets is $4. Let's say 5 tickets is $10. 10 tickets is going to be about $20, right? So I should spend about $20. So number of tickets is my x. That's my discrete data. Well, no, what am I talking about? Is my domain. I'm sorry, I've lost my mind. Number of tickets is my domain, because domain is my x values, my appropriate x values for this situation. The total amount spent just defines the range of this situation. So should I connect the points? Well, the question you ask is, can I buy part of a ticket? Well, no, they're not going to sell me part of a ticket. They're going to be like, you got to buy the whole thing. Like, I can't say, listen, I've only got $1. Can I buy half a ticket and only go on half the ride? No, you got to buy the whole thing. So, no, I'm not going to connect the points because I can't get part. That's the question. Can I get part? No, I can't. So in this case, I'm going to start plotting my points. I have 0, 0. I have 1, 2. I have 2, 4. Then I jumped up to 5, 10. And then I had 10, 20. Now, could I put points in all of these spaces in the middle? Absolutely, because every one of these is a valid point for this situation. Those are all valid points, but I'm not going to connect them, because if I connect them, I'm saying I can buy a half a ticket for $1, and that's not true. Okay, so in this case, my domain is 0, 1, 2, and I'm lazy, so I'm going to put ... 10. Now, you don't put ... at the end, because if you put ... at the end, you're saying that pattern goes on forever, and we've already decided 10 is the most we're going to buy. Same for the range. I would put 0, 2, 4, put some dots, and 20, saying the maximum to spend is 20. What's my rate of change? 2. My equation is y equals 2x. Because there's no, like, it's not like they're telling me apparently at this carnival I have to pay to get in. Okay, now let's look at the second one. This one is different. It says a swimming pool has a volume of 7,500 gallons of water. It's being drained at a rate. That should be rate. at a rate of 500 gallons per hour. Okay, first of all, I know that I've got, so whenever I look for my slope, I'm looking for per, right? So I see 500 right before per. That means my rate of change, I'm going to jump down right here and find my rate of change. Okay? Now, my instinct is to write an equation right away, because I'm an algebra teacher and algebra student and a mathematics student, and as a student of mathematics, I write equations. Like if I had a business card, that's what it would say. It would say, I'm an algebra student, I write equations, I make tables, I analyze data, I know every part of an equation. So my instinct is to write an equation. Okay? My instinct is that I see right here, I start with 7,500 gallons. That's my starting point. B is my starting point. Okay? So I start with 7,500 gallons of water, and what's happening to that water? It's draining at a rate of 500, meaning my rate of change is not 500, it's negative 500, because the water's coming out of the pool. Okay? Now, what's my independent variable? Number of hours. What's my dependent variable? Gallons remaining. Now, when I decide whether my data is discrete or continuous, I always look at the input variable. And the question I ask is, can I have part of one? Can I verb for part of one? So can I drain for part of an hour? You better believe I can. And if I can verb for part of that hour, if I can drain for part of that hour, then I have continuous data. So yes, I should continue. I should do this because I can drain for part of an hour. Okay? So the number of hours describes the domain. The remaining gallons describes the range. Okay? In this case, let's look at this. Okay? So if I start with 7,500 and I'm draining 500 an hour, so I'm going down every hour. Well, okay, so in 2 hours, how much would I go down? I go down 1,000, right? Because each one of these is 2 hours. Okay. So for a domain, what makes sense is 13 hours. Because at 13 hours, I run out of water in the pool. There's no more water in the thing. And I guess I could use my calculator if I had it to figure that out. And I'm probably wrong here, and I probably need to remake this whole video, but let's see what happens. Okay. 7,500 divided by 500. 15. Oh, yeah. I'm sorry. That's 15. Now I feel like a ding-dong. Because you know the number between 14 and 16 is 15, not 13. I don't want to talk about it. So the number of hours that makes sense is 13. Because after 13 hours, 15. Because after 15 hours, I run out of water in the tank. So then what hours, what values, so anywhere from 0 to 15 hours. So for gallons, anywhere from 0 to 7,500 gallons makes sense. Because I could have no gallons, all the water could have drained out, or I could have the full 7,500 gallons left in the tank. So my domain is all x values between 0 and 15. I don't know what my problem is there. My range is all y values between 0 and 7,500. Okay. I know this is tricky. It's one of the most difficult concepts that we learn in algebra. You're going to have plenty of practice. Try not to stress about it. Just, you got to really think about what all the variables mean.